All right. It looks like we have a good group, so we can go ahead and get started. Thank you all for joining our webinar. And today we're going to be talking about mainframe modernization, unlocked, strengthening data protection, and AI safely through application discovery with EJ Pappas and Tate Hamill. So, EJ, I'll pass it along to you.
Thank you, Caitlin. And hello, everybody. Tate and I are happy to have you join us today to have this conversation. I know that when you get a mouthful of words like strengthening data protection and AI safety through application discovery, you probably wonder, what the heck are we doing here? So I just wanted to take a moment to say that let's go to our agenda if we can. The the question about what powers modernization and what does that constitute when we think about modernization on the mainframe. The mainframe is the bell cow for the organizations. It has been the platform that has handled the most important data, the most important computations, and certainly that provided the most value to organizations over the past 20 or 30 years. We want to talk about how you can leverage and utilize that for modernization. How does compliance and risk fit into that conversation? What we're going to do next. Talking about by moving data, and as we talk about modernization, what risks that are associated with. And of course, one of those risks deals with AI and how AI governance is going to fit together. As we have that discussion, we're going to provide all of this into the context of what PKWARE can do for you and how we might be able to both help you understand what the opportunity looks like and help you achieve the outcomes and results that you're looking for. So on the next slide, the simple conversation about the mainframe of why it is important to have this dialogue and discussion, both with vendors like us and with your internal constituents, is that the latest numbers that we see is that there are between 28 and 36% of all mainframe applications are being moved off of that platform to other platforms that exist. So, comfortably 30% of the applications that you have today are going to be somewhere else shortly. Shortly, maybe 6 months, it may be a year, it may be whatever, but the concept of moving from where they currently are to where they're going is an ongoing and a consistent and a top of mind opportunity that exists in enterprise organizations. 70% of the applications that exist on the mainframe are mission critical. So they are the most important and key applications that exist within an organization. They are the processing powers that happen at credit card organizations. They are uh, the the keys to the most critical data that exists and the most simplest and most direct way of you interacting and engaging with your customers. So those applications, when they are moving, introduce incredible risks to both your proprietary and unique information and to the private and sensitive information that exists within the organization. And to that end, there are a litany of compliance mandates that suggest you need to worry about these things. So worrying about these things means that you are identifying the sensitive information or identifying the kind of information exists in your organization. That being the case, we have to worry about which data you have and where that data happens to live. So next slide. When we talk about the risks of modernization, modernization risks are interesting. First off, the concept of modernization means many things. It means application modernization. It means integrating into the cloud. It means infrastructure modernizations, data modernizations, operational modernizations. There's all kinds of words that we can put in front of the word modernization when it comes to the mainframe to get to the area that we are working on. But the simple reality and the focus that we're going to have today is around data and application modernization. And in that way, when you are taking data from applications that exist on a platform that probably haven't been updated, or the people that have written those applications don't work there anymore because they have retired or moved on, or the people that are maintaining those applications are simply worrying about keeping them running versus what is existing within those applications, it means that the data that exists in those applications could be sensitive, could be proprietary, could be unique, could be the secret sauce for your organizations. So taking that information and moving that into an AI model means that you're taking your interesting and unique information and allowing it to sit inside of an LLM or some other compute, some other uh, uh, engine that is sitting outside of your organization and providing risk. The other way that we see this happening time and time again is that you're taking your sensitive mainframe information and moving that production data into dev and test so that your new, more nimble applications can work fast and effective and be unique. Except again, you might be exposing personal information or proprietary information that goes back down. The only way that this makes sense, the only way that this works is if you're able to understand data at a field level and understanding whether that information should be sent, can be sent, or if it is going to be sent, it should be sent in a way that is safe for the organization and for the users themselves. And so I tell you this, and I say that this is important, but is it only a vendor telling you that this might be a good idea or this is something that you might want to do? Nope. I'm going to tell you that there is another factor that you need to consider. So next slide, Caitlin. The government. The government oversight suggests that this is not a thing that you might want to do, but in fact, something that you need to do. So whether it comes down, the left-hand side is just a quick, short study of some of the opportunities, whether it's around PCI or HIPAA or FDA or FISMA or the DOJ or even our own executive orders of understanding what information you have, understanding if it's classified, understanding if it can be shared, understanding how it can be shared, and what are the components of the applications that happen to be there. But rest assured, and I know that it is a comfort for all of us that not only has the federal government decided that this is a good idea, but the states are racing to provide additional scrutiny to this information. So, listing here around something as simple as data tagging and classification and providing consent are Delaware, Iowa, Nebraska, New Hampshire, New Jersey, Minnesota, Tennessee, and Maryland. So, um, and this doesn't talk about Texas and it doesn't talk about California, existing acts that have already been in place and also ones in Virginia. So know that it is a good idea that you identify your information and understand what you happen to be, but it is also mandatory that you do so. So next slide. How does this, how can you do this? How can you work through the maze of regulation and understand how to stay current with your own applications and data within your organization? PKWARE. And when you say PKWARE, you go, oh yeah, that good old company that has been around for 40 years, that has been a part of your infrastructures forever. The zip people, the people that have been compressing and securing data across your organization for as long as you have been working and your parents have been working within this organization, is a product that is a platform that we can provide you value for this particular endeavor that you have. And who works with us? 21 of the 25 commercial banks, 60% of the card processors, 60% of the insurance companies, and 30% of the Fortune 500, Fortune 100. So what that's telling you is that the products that we talk about and the capabilities that we are going to discuss today are capabilities that are battle tested through the enterprise. Organizations that are across the globe that are um, having data centers sitting in multiple on multiple continents across multiple countries, we are able to provide you value within that particular place. So next slide, Caitlin. Specifically, what we talk about in terms of benefits are the 5 benefits that you see on your screen. And they talk about compliance and modernization, preventing data leakage, de-identifying data in lower environments, and ensuring the AI governance that we've been talking about. Specifically, we are going to talk about the modernization capabilities here today. So PKWare can do lots of things. We're going to just kind of focus our sharpen our pencil, focus our lens on a couple of particular use cases that we think would be interesting for the organization and for users here today. So next slide. The two use cases that we're going to talk about is one, identifying sensitive mainframe information that exists in your applications and in the data sources that exist on the mainframe. So by identifying sensitive information, it allows you to know what information exists within applications and understanding both the sensitive information itself and the metadata surrounding it so that you can understand what data can be shared, should be shared, or might be shared, and maybe the data that shouldn't be shared that might be called more effectively through other means of keeping data safe in the platforms that it happens to be. The second use case that we're going to talk about is cloud migrations and moving data, financial, health, personal information that exists on that mainframe to other areas in the most effective way. So whether we should take that information and just move it as is, whether we should move it in an encrypted manner, whether we should move it in a masked and protected manner. And by understanding that information and moving it effectively, what we're doing is we're going to reduce the opportunity for you to accidentally share sensitive information, basically creating the breach yourself in your own organization. And lastly, allowing you to have an ability to map that information effectively to know where it started, where it's moving to, and who is sharing that. So that legacy information that you kind of get for free within our products allow you to be able to move forward to that. So I've told you a lot about how this works, and I've told you how this might be important. The next thing I'd really like to do is allow Tate, who has been very patient, and thank you for that, Tate, to show you the next steps. So Tate, if you will, Caitlin, next slide.
Hold on here. I think, hopefully you guys see my screen at this point in time. Appreciate that EJ is an excellent tee up and what we're going to talk about here, or certainly what I'm going to show you. So I guess the first thing I want to do is introduce the PK Protect platform, the user interface that you're actually looking at right now. Something that EJ and I and the rest of the organization talk about is how similar or the same it is, and from a workflow user experience, regardless of what it is that you're trying to find sensitive data in, right? So I think you talked about how this is an enterprise-wide product. So whether you're trying to scan S3 buckets, MariaDB databases, DB2, or in our case, application data sets, it can all be done from the exact same user interface. And that similar workflow obviously makes for the scanning team, as an example, a pretty easy, enjoyable experience when it comes to at least supporting software. So with that said, what I'm going to do here is I'm just going to create a real basic task, and it's going to be a discovery task. Why am I starting with discovery? Well, as you can imagine, if you wanted to try to protect anything, you actually kind of need to find out where that's located first. And that's also part of that whole reporting, visibility, auditing perspective, where you need to be able to tell the auditors exactly what you have, what data sets it's in, what are you doing to protect it, etc. Right? So that's part of this audit trail. So the first thing we're going to do is discover. All right. So what I'm going to do here, and again, very similar approach here, just going to give it a quick name, demo one. You're going to give it a quick description of what it's doing. I'm doing a demo. And like I said, before you can do anything else, you must do the detection or discovery process, right? Can't protect it until you find it. All right. So we're going to go through this detection process. And then what I'm asking it to do is I can have it scan the entire file. But again, if it's representative data, you would just simply do a statistical scan on a statistical sampling. So in this case, I'm going to scan or sample the first 1,000 records for this particular task. And now the next thing I have to do is select my target. Nice thing is that the way that our solution works, and again, it's around application data sets in this particular instance. And so you can actually choose to scan a data set by simply typing it into the data set search up here at the top of the screen, or you can actually do a search for data sets associated with the application. Right, so a lot of scanning teams will choose to scan their most critical applications, got a pecking order, and it's pretty nice that you can just say, hey, show me all the data sets associated with this particular application. So when I do something like that, right, so I can get a listing of data sets here, and I do have my screen kind of crunched up so you guys could see it a little bit better, but from a selection standpoint, I'm just gonna kind of hand pick a few of these here, and just to let you know, you can choose to scan the entire application. You can be selective about what you scan, whatever. But again, you can select the whole thing or not. But anyway, you select the data sets that you want to scan. As you can see, I can identify whether a data set is encrypted. As an example, IBM pervasive encryption, right? We work seamlessly with that. So you got some production data sets that are encrypted with that, not a problem. But nonetheless, I've chosen some data sets that I want to scan associated with my application, all types. When I selected them and hit add, I've confirmed their selection down here in the bottom, and I simply click on done. Okay, this brings me back to the main screen. So again, I've got a task name, description, a task type, sampling. I got the target site I want to scan. Now down here, we've got two sections. We've got a policy that we have to select, and inside that policy are a bunch of sensitive types. So you see over here on the bottom, I've got a total of 4 policies that are already out of the box policy types that you can choose from. Here they've been modified for Hadoop, but again, you can share these sensitive types regardless of which platform or environment you're gunning for, or you can create your own customized ones. If you think that ZOS specific policies are better, then that's fantastic. I've got some of those as well. So anyway, what you still need to do is that whenever you select a policy that you want to scan for, you see that I selected just one out of the 5 policies. But when I selected that one policy, it chose 3 of the predefined sensitive types in our sensitive type field. And as you can imagine, since I chose PCI, it's going for the credit cards that you see here. So you see there's little gray checks right there. So I've chosen that particular policy, and I'll go ahead and throw in CCPA just because it'll give me a few more sensitive types to scan for. All right, so the task has been set up. And again, this is the same regardless of the target, regardless of the environment. The workflow is extremely similar, whether it's a database, structured, unstructured, doesn't matter. So I've got my policies now, the sensitive types associated with them, and all I do is click on save and execute. So what's happening in the background? So right now, if you got encrypted data sets, we do run APF authorized. So if it's a production data set, we'll run out, grab, as an example, the RACF cert, decrypt the data, pull in the records. The records never leave the mainframe, so we're not taking the data anywhere. And then what happens is we will unpack decimal data fields. We will adjust logical record lengths. We will translate the data from EBCDIC to ASCII. And then we apply a schema over on top of it, and then we start doing our discovery process. So what ends up happening in the end here is you'll get some results here. It says, hey, we found some data sets, and we skipped a couple of files here. And one of those things I wanted to show you is that the very first thing that we do before we even start the discovery process is we do data validation on the field. I'm going to explain how that magic happens in a moment, but the whole point is that before the discovery process even kicks off, we do data validation where we can detect dirty data in a particular field, right? If you're supposed to have integer data inside that field, yet there is string data, we will point that out and tell you there's a problem. This obviously leads later on downstream to AI infrastructure problems, or when you start sharing data with other parts of the organization, now you're corrupting the information downstream. This is obviously a data governance problem as well. So I guess the point I wanted to highlight is we will validate the integrity of the data before we even start scanning it, right? So it's a fantastic little, I guess, a security option that we have in there that helps you do a little gut check on your applications that are writing those data sets. So then we actually look at the results of the scan. And again, I tried to keep it relatively simple here. But again, over here on the left-hand side, we actually have the sensitive type that we're looking for. All right, credit cards with a dash separation, digits only, space separation, and then we look at we got a national personal identifier and a couple of social security numbers. All right. So what we do is we find a couple of data sets here that we chose to scan and the type of data set that they are. And here's the thing. We were looking for field names, and you're going to ultimately find out how that happens. But I think most of you know there are no field names in those application data sets, right? That just simply those data structures don't exist anywhere. Streams of binary data often, right? So that field name was abstracted, and I'll tell you how we do that. But nonetheless, We scanned through the file. We located a field called CCNO dash dash. We told our discovery engine to read or sample the first 1,000 records. We found 1,000 matches, and it gave us a score of 100. Now, here's an example where we found only 908 matches out of 1,000, giving us a score of 76. You would think that score would be closer to like a 91, since it's basically 91% of that. But the problem was that this field name, and I know it's basic, but did it for this demo here. This CCN obviously is a credit card number, but the regex that's looking for that field name, that value is not in our regex scan. So it said, hey, I did not find, or I'm looking for something, and I found the CCN thing, and it's not in my library. So I'm going to give you a no. And even though this match count was close to 91%, I'm lowering the confidence on it to 76 because the field name doesn't quite match up. Right? So what you can do is you can feed that right back into the result and say, hey, next time you see that, this is that feedback loop, right? So next time you see that, I want you to grade that higher at a 91 confidence as opposed to 76, because now you know that CCN field is something that we're looking for. And then just to highlight one more example, here's probably some bad coding practices. Here's a field called custom. It really means nothing to anybody on the surface. And here you can tell naturally we have a field name match of no. We only found 17 out of 1,000, giving you a confidence of 1. Now, I'll be honest with you, that could be a fully legitimate field, but because the field name is reprehensible, certainly not helpful, and then the match count and the scores on it are just as bad, I think it's sometimes worth looking at that information to find out whether or not that's legitimate data or there's something wrong with the application or not. But nonetheless, got a really low score, but this type of insight really does help analyze that information. But once you have done that, now you can actually label that information. Okay. So I'm going to stop for a second and just kind of take a deep breath because I get real excited about this stuff. And I know I could see EJ, he's all excited too. But so this is a very similar experience across the board, right? Whether it is what, we've got these agents or IDPs that run in the cloud and databases on-prem, in the cloud, for files, Hadoop, everything across the board, right? So this overall workflow and the way the results are presented are extremely familiar and similar, regardless of the target you're going for. Did I miss anything, EJ? That makes sense?
It made sense to me.
Okay.
But
All right.
I would tell you that I think the two other pieces that you have here on the screen that are important for our audience is you were talking about confidence, and what confidence means for a customer is that after you do a scan of a database or of a file server that has files in it, you're going to either find sensitive data or you're not. And so the concept of delivering against the hoped for scan is the results that you get. And normally or traditionally, what you would do is then you would take those results and review those results and decide if you did in fact get 908 matches on 1,000 records that you ran. What we've provided, the PKWARE PK Protect product provides, is that we are able to utilize analysis of this to say, based on what you have told us or the value that you have associated with the field name and the records that we've read and the hits that we have, we're going to give you a confidence number of that. So what it means is that if you had 1,000 records here or 1,000,000 records here, what we can do is we can allow you to filter through and say, you don't need to look at the ones that give you 1% or give you less than 50 or less than 30 or some number that you have. You should look at the ones that have the highest accuracy so that you don't have to waste your time looking at false positives or looking at columns that have the wrong kind of data. So what confidence does is it streamlines your ability to do your results of this. The scan is merely the activity. It is the processing of the information that becomes interesting. So the second thing that Tate was talking about, and he has said it a couple times, this PK Protect interface, as you see on the left-hand side, it says ZOS data sets. Underneath it, it says RDBMS, and underneath that, it says Hadoop, and it says files. It is the same interface. So if you in your organization have data that lives in a bunch of different places, you can utilize this same product, the same PK Protect product, and derive the same value from it. You don't need to learn a different product for scanning AWS than you need to learn for scanning Google Cloud, that you need to learn for scanning Oracle versus scanning on-prem databases or on-prem and file servers. So we give you consistency, allowing the same team member to be able to cross borders, cross boundaries around data so that you can leverage the value of the information that you're getting out of these capabilities versus having to learn 5 different tools to just get to our results.
Right.
So Tate kind of showed that seamlessly and showed the fact that we do this. But Tate, I really would be interested for you to be able to help them understand how in the heck did we get to field name? How in the heck?
Yeah, that's oh, well, hey, wow, what a nice segue there. EJ didn't know you're going to do that. So, yeah, so how does PK Protect provide this level of application support, right? So, I think everybody knows scanning structured data such as like DB2 and IMS databases, it's fairly common. Structured data is easy, at least comparatively speaking. Now, discovery inside ZOS application data sets is where the story really typically falls apart. ZOS data sets are often just streams of seemingly unstructured binary data, right? So being able to accurately find anything, let alone sensitive data, is not possible without help. Field headers, other data structures just simply don't exist within the data. And most of the time, you need something like a data definition to know how to accurately read this data. And this is really the strategic difference between our solution, PK Protect for ZOS, and the others. It's really the only solution that performs what we call application discovery, leveraging application-specific data schemas for accurate and precise discovery. And that's just what our application discovery does. Now, I'm going to show you a few use cases, and then we could jump back into the demo here, all right? So we've given away enough Pac-Man machines at Share. I figured this was appropriate. But anyway, so on IBM ZOS, data leakage, it isn't just a security incident. It's a breakdown in AI information architecture. You need to treat the schema essentially as the control plane. Use schema-driven metadata to strictly gate what AI pipelines can see and learn from, and then masking or de-identifying sensitive fields at the ingestion point. So this is where you also enforce a zero trust at the schema level, so only policy-approved elements pass from data sets into data model features. And then finally, you close the loop with verifiable audit trail dataset field AI training set. So you got SMF, RACF evidence can prove, excuse me, who accessed what, when, and under which policy. Now, I have one more use case I want to highlight, and then I will show you how this all works. So, as we alluded to, the strength of our solution lies in our approach. It's the metadata. It's these schemas that I was alluding to before, right? So we got mainframe metadata. It's organized information that really tells what data is on the mainframe, where it came from, how it's used. It includes details like who owns the data, when it was created, its format, structure, how different pieces of data are connected. Now, metadata also covers how files are managed, protected, and tracked. And specifically, it describes data, gives facts like name, format, owner, dates, shows the structure, explains how files and data sets fit together. And then the control management side includes rules for access, archiving, security. So this is the part I've been really excited about. I'm going to show you how our application discovery can gather that metadata and turn it into compliant-based reporting. All right, so I think I got to get out of this. Okay, so this is the PK Protect Application Studio, and basically this is the metadata consumption front end here, where basically we are reading schemas. And when I talk about these schemas, I just kind of want to show you this here. This is an example of some of the data, the metadata that we collect when we do our application discovery, right? So we're doing this for each of the data sets associated with each application, right? So we're looking at source and copy lib and JCL, and we've got program names, step libs, etc., right? So it's pretty intrusive. We're getting in there. You point us at your source code. We basically find out how your application writes data sets, and then we generate a schema for each data set associated with that application to where you've got metadata like this. And then inside, we've got this data definition blob, which is what this guy is. And that's that data record, right? This is that record layout. So now you have an explicit layout of all the fields, starting position, display length, etc. So now you actually know how that application writes its records. Now, this is obviously a huge boon for anybody that does application integration, etc. So, like I said, this will be able to you'll be able to leverage this from a DevSecOps perspective, and really many different ways here. So let me go ahead and get back to this. I wanted to show you. So here I've just got an application, and again, we're just tapping into our Easy NoSQL database that comes free on the ZOS with a ZOS operating system, and they're just vSAM database files. But this thing, it's extremely fast and efficient. So anyway, so I've got my application studio here, and I've got an application up here that's loaded in there. Got some basic program information, data set information as well. But when I click on the schemas, again, this is the stuff that I was showing you before, right? So we've got the schema layout for this particular data set and this application. So all that information is sitting right there for you, which is it's fantastic. It's really what you want to look at. But so when we get to say like the discovery side, all right, and this is kind of an area I want to focus on before I get to the SBOMs there. So the discovery side of things. So you can manage your expectations a lot here and test what if scenarios regarding de-identification based upon use cases, right? So two use cases we highlighted before, jumping back into the demo mode, were AI infrastructure and SBOMs, right? And we'll cover those, of course. But first, I want to highlight, these few other highly popular use cases, right? So I'm going to say the first one, probably one of the oldest ones, at least certainly PKZip has played this one a whole bunch, is sending data to external clients or partners, right? So that's a particular use case, but that also kind of drives, maybe based upon who that partner is, the type of security or de-identification you might want to take on that data. So if I've got an external client here that I want to send, again, think that this is a policy, but think of it also as a use case. I would say discover sensitive fields, right? So it automatically labels the high-level qualifiers associated with this application. We know this application generates sensitive data. That part's good. Well, what can you tell me about it? Well, here's the layout, right? We were looking at the schemas before, but then we start seeing this other information. So now if you wanted to send records to an external client, you could test your what if scenarios by clicking on the simulate PII protection, right? So based upon this use case, I'm sending company information out to an external partner. What might I want to do? All right, well, you might want to absolutely mask certain pieces of information, right? We know credit card numbers are often the last 4 digits are exposed, but everything's masked. You might actually choose to AES 256 encrypt that field using variable length field lengths and being able to expand that. But nonetheless, based upon what your policy is, maybe you're not sharing that field, right? You can be explicit about what goes out and what doesn't. But again, using a policy, testing the what if scenarios, and applying de-identification to these production data sets allows you to give you an insight on how your production data is going to behave when a copy of that is made, and then you de-identify it with one of these policies. All right. Another highly popular use case, and I know there's a lot of guilty people on this call, is copying production data to your lower environments. Right. So what do we need for that? Right. So this becomes, this is one of those things where, this is a pure de-identification play, as developers need to be able to do displays and compute against various fields that correctly mimic the production data record layout and behavior. So how do you do that, right? So if I want to say, hey, I want to copy production data to the lower environments, well, here's the policy, here's what it's supposed to be doing. And you can see there's a lot of format preserving and name shuffling, that kind of stuff going on here. So when I hit the simulate PII protection, now you're going to get a whole bunch of data. Looks like I'm passing production data over. But again, this is just fake, safe, and compliant data, right? So this is how that policy is going to treat a copy procedure from production to the lower environments, so that when your developers get down there and they do a display and it shows up in the log, that credit card field that they just displayed ain't the real McCoy, right? And that's exactly what that's what our de-identification can do for you. Okay, so we talked about AI pipelines and hybrid cloud as well, right? So AI pipeline, very important that you're not sending the wrong data, the sensitive data, or the data you just simply don't want in your AI models to be ingested and shared out, right? So again, sometimes that's a format preserving, maybe you're de-identifying, maybe you're masking, or maybe you're not even sharing that information, but it falls along the same policy. But this is what we're talking about, right? This is, AI, your AI pipeline is a governance issue, right? It's data integrity, and it's the garbage in is equals garbage out. So not only do you not want everything to go into your AI pipeline, but the stuff that goes in, certainly that's sensitive, you need to be cautious of that, right? So this will help you determine how you want to treat the AI data you choose to feed into your models, right? So very important, but this has become a new high risk area for organizations because everybody's going like gangbusters. And of course, you've got a ZOS mainframe, you've got, and one of the newer ones, you've got a built-in all over the place, right? It is just a part of how the system runs, right? So it is a part of what we do now going forward. So now it's just a matter of how is your organization going to treat that data that's fed into that? And it's an extremely important thing for organizations to resolve. PKWARE can certainly help you out in understanding what should go in and not, as well as how to protect that information. And then finally, my last use case before I get to the SBOMs is hybrid cloud, right? We know you have to share information with hybrid cloud apps sometimes. And, my principal position certainly is to keep the data secure on a mainframe and have that hybrid application use a secure API and grab the encrypted field that it needs and only what it needs, right? Pull back only what it needs. So as an example, if you've got 44 fields in a record, but your application only needs 1 or 2 fields, why would you send all that information from the record, right? In the old days, you had to send it all, right? Or you would send the entire data set. But now I'm telling you, you can be explicit about what is shared. And if you only want to send 10% or 5% of that entire record, why would you send 100% of that? And if you do that a couple thousand, 100,000, 1,000,000 times a day, those transmission costs of 90%, 95% waste, that adds up quickly. So being explicit about the information that you're choosing to share with that hybrid cloud application is an extremely important step. But our PK Protect and the schema link technology that sits behind it will help you analyze that information and help your application integration teams do the right thing and share only the right information. And then finally here, just going to kind of close this out. And I was going to say, you can do comparisons against data sets from checking out the different layouts and seeing how they differ. But really the SBOM part is the part I wanted to get to here. And that is because we've got all this fantastic metadata that's just stewing in this encrypted easy NoSQL database. Obviously we're able to help leverage that very significantly with the SBOM requirements, so the software billing of material. So anybody remember Log4j? I think that came out in about 2022. And it nearly broke the application and software and open source world. I mean, it really, I remember what happened here, but every organization was scrambling to find out where in God's name Log4j was hiding in their enterprise, right? And they only to find out that it was nearly everywhere, right? A very widely used open source library, and it had serious vulnerabilities. So how did organizations find it? Well, there wasn't a lot of SBOMs around at that time, but that's exactly what SBOMs attempt to do. So they attempt to break down the components of a piece of software and be able to tell you the interdependencies, how it's licensed, hashes, this and that to make you feel good and give you a nice audit trail for your audit requirements. But you know, the reality is that information is hard to come by when it comes to your application data, right? So what do SBOMs look like with applications, right? So this is what we do, leveraging PKWARE's schema link metadata, and we cross-reference with your DevOps environment for an accurate depiction of your production applications in their components. This will help you with your reporting obligations, and while these are not mandated for every organization yet, they will be. But anyway, so we got this relevant information. We support the Cyclone DX format right at this time. And again, just export it out, and there's the Cyclone DX SBOM, right? So that is an example of what the application studio, the PK Protect application studio could do for you once you've actually gathered that schema information through our PK Protect platform. So I think I've said a whole bunch of stuff there. EJ, did I miss anything? Was there anything else you wanted me to cover? If not, then I'll just kind of throw this
Much-
back over to you, and I can
Appreciate that.
share that
Yeah, you
last.
should. We're
Here's the
we're down
last.
to a few
There it is.
minutes, so let me just let's pop back to the last slide and we can wrap this up. So
Yep.
the Tate went through a number of scenarios and a number of pieces of information. The key takeaways that you should have from this is that what understanding what data you have on your mainframes, understanding what data exists inside of those applications, and understanding where you want to send that information is both a requirement to the federal and state government, but most importantly, it is the key component and foundation of what modernization means. So organizing data to understand what you have, where you have it, where it needs to go is of vital importance. Being able to secure that information and utilizing the data that we found in both our discovery scans of the applications as well as the SBOM creations or the bill of materials of having formatted, organized ways. SBOMs are something that have existed on in Linux and in Windows and in other platforms all the time. We're introduced those to Mainframe to allow you to secure that information. PK Protect allows you to enable the remain to the organization by making the data feel common and make it feel consistent in terms of discovery and in terms of reporting. And last but not least, we can adhere to any of the state and local mandates that you have and give you the best opportunity to be successful. So PK Protect allows you to step into this world of modernization and be confident about both understanding what data you have, understanding how your regulatory requirements exist, and what you need to do to be able to move forward. Caitlin, I don't know if we have time for any questions, but I would open it up to that if not. If you don't have questions, by the way, please feel free to reach out to us and we can answer any of those questions offline.